Welcome to Gears for Ears, the Klingelnberg podcast.
Ladies and gentlemen, welcome to the second episode of our Klingelnberg podcast, Gears for Ears, the Klingelnberg podcast for the gear industry. This podcast is coming up regularly with different topics, deep dive into gears, but as well lots of topics relevant for the gear industry. It's available on YouTube, on Spotify, and on different other podcast platforms that you probably know very well. Maybe you remember last time we had a chat here. I had a chat with Matthias Göken, our Director of Operations, and we were talking about actually how we build machines, how we handle the situation in a high variability of different machines, the very small lot sizes, very, very high quality demands. Now, today, we have a different guest. We will change a little bit from things we can touch to the digital part. And my guest today is Daniel Meuris. Welcome, Daniel.
Hello.
He is responsible for machine tool software and the digital, I just want to say the digital stuff and digital within the Klingelnberg group. In fact, Daniel started his career in Bochum University as a researcher with a focus on product, service systems and software. So software, actually, he's got software in his blood, I would say. And after joining Klingelnberg, he had various positions in Klingelnberg machine software. And in fact, Daniel was the guy who started the digital initiative within Klingelnberg. I think we can say that, right?
Yeah, maybe.
Now,
with others.
Yeah, there are a lot of other experience, and we will talk about that now and take a little time for that. But let's start with your experience. From what I know, before you joined Klingelnberg in your university time, you did not have previous exposure to gears. So it's not natural joining a gear company like Klingelnberg. So why did you join Klingelnberg? What made you join Klingelnberg? What attracted you to Klingelnberg?
Yeah, indeed. Gears, when you study mechanical engineering, gears are just one 2-week lesson where you learn how to calculate them. So then you do it and then you're done. Then you do the next machine element. And when you come to a company like Klingelnberg, it's the complexity of such a topic is so unbelievable high. I was really baffled back then. But the argument for me to join Klingelnberg was really the amount of high quality people that you have in order to build something like gears. That was really amazing for me to bring together people to push this complex technology. I really loved this idea.
Okay. Our topic actually today is software at Klingelnberg. So would you say we are a typical machine tool builder?
Yeah, no. I mean, I just had a customer conversation back then where I had to explain customer the difference between like gearing machine tools and common CNC machines. And the software stack that we are handling here at Klingelnberg is really unbelievable high. So we need so many solutions in order to teach a machine how to do a gear. That's basically our job. Yeah? We are creating systems that take the idea of a gear into concrete movements of axis. And that's therefore you need a lot of software and a lot of smart people to do this.
How many people actually are working in software at Klingelnberg, all in all? So when we take together the people working in machine tool software, people working on CMM software, the digital people in India, how many people do we have in software?
It's roughly 80 people.
80
people.
And that does not even include the PLC people, which I would also consider software. It's included. Oh, it's included. Okay.
Yeah, so in my area we have, it's hard to say where to cut, but roughly 65 people among the whole stack of a machine.
Okay. Wow. That's a big number.
Yes.
And actually, what we're talking about kind of connects to my last podcast with Matthias Göken, our director of operations, because what I discussed with him is our mission at Klingelnberg is really to bring highly technical, complex solutions to our customers with excellent quality and, in fact, small lot sizes. And basically, I mean, you talked about the software stack, the variability of software solutions that we have. That kind of connects to the mechanical side, right?
Yeah, I mean, what you have this external variability, and this is of course high. Yeah, we have. I think no machine is like the other when it comes to the software, but our task, our challenge internally is of course to keep the internal variability low. So the effort we need to put in to make some things configurable, to make it robust, to make it work for customer A, but not for customer B. So that's a hard part of the work.
In fact, we started talking about software. So what kind of software does Klingelnberg provide? I think it's not only something that just makes the machine run, right?
No, it's, I mean, we start really close to the sensor, let's say, yeah, with the PLC software, which basically sets the parameters of a machine. Then you have the NC stack above, where we look at the concrete axis movements. So
that's the G-code, basically. That's where we generate G-code.
G-code, right, exactly. And then if you imagine a modern machine made by Klingelnberg, you can think of like 6 axes in a 3-dimensional space where you combine tool movement and workpiece movement together to create something like a gear geometry. And this cannot be handled by an NC programmer anymore. So we put above a whole stack of HMI software which does the calculation. And then you come at the limit of a machine, and then you have other softwares in the context of, I don't like the word, but Industry 4.0. So where you aggregate the data, where you try to conclude things. And beside that, of course, with Klingelnberg, you get the whole suite of calculation software. So in order to design a gear, you need a lot of smart software. This is also what we do.
Wow, that's a lot of stuff. Yeah. But before we talk a little more about the fancy digital stuff, I would like to start talking a little bit about legacy software, something nobody likes. But I mean, we're in the machine tool industry, and machine tools are easily running more than 10 years. I mean, I see a lot of machines out there, also from Klingelnberg, but also from other providers that are 20 years and more old. So how can we deal with this situation?
We can't, no, I'm just joking. Yeah, it's so the problem is that software in the past was not really a thing that was managed. So you had people who do software, who took their decisions, and some decisions were really good, where we today are in a really good position. Some decisions were not so good. And of course, you have to keep that in focus. Beside the exciting new projects you do, you have to have in focus that you need to cover also these topics step by step. Yeah, so it's really an incremental process here where we do this.
So you already talked a little bit about the challenges, but would you say legacy software is a bad thing, or? I mean, there's a lot of, you just mentioned that a little bit, good and bad decisions, but also there is a lot of know-how that has been put into the software over all those years. So would you say legacy software is bad, or is that just something we have to deal with?
Yeah, I mean, I don't think that judgment here helps in the situation. Of course, there are legacy softwares which are easier to handle today. So for instance, if you take just for instance a Fortran code. Fortran is a really engineering-like programming language where engineers can easily connect to, way easier than, for instance, an old Visual Basic code. And so there are legacy softwares which are more a problem than others.
Okay.
And this is very close tied to in the end, to the operating system you're working on. Yeah? So, like instance, Visual Basic 6 may cause problems in the future, but Fortran, I think, may never cause problems in the future.
Yeah. You just mentioned, and that's a nice example, I think, Fortran as an example where engineers can easily connect to, how the code works,
yes,
and what it really does. And I mean, if I look through our software team, I mean, it's not like a team you would maybe see at Microsoft, for example, where basically informatic guys are working on the software. It's a little different. We have a lot of engineers working on our software. So what qualifications do we have and what qualifications do we need in our software team?
Yeah, I mean, in the past, people who were electrical engineers, at some point in time, they got a desktop PC and they started programming. That were the first programmers for machine builder in the past. Today, this field is way more heterogeneous. So you have people who are focused on UI design and user experience. You have people who focus on parameters of the machine movement. You have people who are focused on architecture. You have people who are focused on data handling of data flows in real-time environments. So I wouldn't say there is a special skill set where you have to, which you need to be a part of our team. It's more, you have to love technology. That's way more important than loving a certain amount of a programming style. Yeah? You need to get in touch with technology. You need to connect to the machines, to the customers, and that's the most important point.
Yeah, connecting to engineering. I mean, customers in the field of engineering of gearing is not what a typical software guy would like to do. So that's probably a unique qualification we're looking for. And not for every programmer, I know that, but at least for some, because we're also trying to pick up our customers' challenges, understand them, and try to find solutions. And we also need those people that can connect what our customers are looking for, what the challenges are, to what our software can do, and somehow bring that together.
Yeah, I mean, you can basically program anything. Yeah, there are nearly no limits. But our challenge is really to deliver a customer solution despite increasing our internal complexity further. And that's really the tough task. So doing as less as possible, but delivering on time for a customer. And this is really a complex task where we really need to understand the customer workflows. And this is in the field of machining way different than delivering a cloud service for project management or something like this. Yeah. That's really a difference.
Absolutely. If I'm looking back a little bit, and you just touched that a little bit during what you explained to us. I mean, if I look, I don't know, 20 years back, basically we started from, I think we started software way back than that, but we started from a single solution. So there was some piece of software for gear design, like Kemos. There was a piece of software running the machine. There was a piece of software doing the metrology part. And that was already 20 years ago, we did the first steps towards connectivity. I mean, when we talk about digital, I think that's the first step. So if we look at closed loop, for example, if we look at the Kemos database where the designer hooks on, also the machine tool hooks on. So those were the first steps I think we did already back then into the digital world. And that connects also to that you saying I don't like the word Industry 4.0 so much, because a lot of buzzwords we've seen there is something we've been doing 20 years back, right?
Yeah, I mean, we were in the situation where we needed a database-like structure even before databases were widely accessible, also for our customers. Yeah, so there was a need in the past to design an own database system, which today is in some cases file-based, but it's still working, and it's still connecting new machines and old machines, and it's delivering customer value. So,
And that's funny, because also this is sometimes a restriction we're dealing with. I mean, yes, we can like when we connect the bevel gear design to the machine and we talk about databases, we can never forget that there are customers out there having 15, 20-year-old machines, and they're still connecting to these databases. And they're still working with the information that we're creating today. So we always have to keep in mind how to connect the old machines to the new fancy world.
Yes, indeed. I mean, of course, that means if we are doing new ways, or if we sometimes when we get the chance to start on a green field, then of course we hook with modern state-of-the-art technologies. But again, here's also you need a fine sense for how many innovations you can put into a software system. Because when you look at the way data is handled the last 10 years, there have been, I don't know, plenty of changes. What is now the coolest piece of software to do data storing? And so I think we learn from it, and we get a good idea of what good decisions are made of.
Okay, very good. Now, the next step after connecting the different devices, piece of software, I think is visibility. If we stay in our picture, so that basically means understanding what is happening in my production. I think that's a step we have already taken, and we're offering quite some solutions to our customers.
Yes, so for me, the next level of customer value, once you have connected your systems, you need to make visible what kind of data is interacting in your system. And if you, for instance, if you aggregate data from a machine tool, then you need to know what kind of load behavior do I have on my tool spindle, what kind of measurement reports are flowing through my network. So and this is then the step where you go beyond a single machine. So this is where you're talking about about web technologies and to show actual data. Yeah,
where you start understanding what is happening in your production, not only in a single machine, it's also part of it, but also where you understand can understand what's happening in your production.
Exactly.
And then I think the next step is understanding why it's happening. So bringing transparency and visibility, I think, is a precondition to get there, right?
Yeah, absolutely. I mean, if you just make a machine problem visible, and you make the tools you are using visible, the next step is, of course, to connect these two aspects in order to understand could a tool lead to a problem in your manufacturing process. And that can only be done by connecting these data points. And that is the hard work we are also doing to bring together all these heterogeneous data points. And the other problem is, of course, that nobody tells you exactly how this should look like, because no one has ever seen it. So that's also a good example for where we go new ways of defining user stories, interacting with customers, and creating something new, which they also haven't seen yet.
Absolutely. So don't worry, we will make it a little more concrete in a moment and talk about solutions that we're providing. Yeah. But just to get the broad picture, I think then the last and final steps, part of that is future, part of that is maybe also available already, is then predictability and adaptability. But that's only possible when you have the transparency to understand why things are happening. Then you can start predicting the future and adapting to what is happening in your process.
Yeah, I mean, the whole field of predictive maintenance and predictive quality, these are two big topics for us. But you only can go this way if you understand your past. Yeah? If you understand the past of a machine, then you can predict its future. And this is where we are going, and where we are heavily interacting with customers. Because, data is king.
Yeah.
So we don't create this data by ourselves. but we are the ones who understand machine behavior, and so we want to bring together this and deliver benefit for all our customers. Yeah.
I was just smiling because I think it was 2 years ago. I had a chat with a customer, and we talked about data, and he told me data is king. And this is something that is in my mind, and we're discussing that all the time, and it's kind of getting into people's minds. And I think it's true. It's about having data because we need information to achieve visibility, transparency, and then come into the future of predictability and adaptability.
Yeah, but so the thing is, what makes it really difficult for our field of industry, and maybe for others too, is you really need to understand the domain. Yeah? It's not just throwing some data in a model and then you are able to derive things, because usually you derive the simple things that everyone knows. But there are hard topics where you really need to shape the data in a form that you get the outcomes you want to have.
And it's not only about shaping the data, it's also about making sure that, I would say, it's not only data is king, but good data is king.
Yes, of course.
And I think that is actually where also we need the understanding of the process of the gear of the machines in order to understand which data will we need in the future. Because in the end, and we will touch that, I think, in a minute, when we talk about things like big data, about machine learning, about AI, in the end, if the relevant data is not available in my stack, we will not be successful. I think that's a precondition again, that we have the relevant data.
Yes, and the relevant data, and now you could say, okay, we just collect all data, and then you get really in problems because of the amount of the data. So if you take a modern gearing machine tool, it uses about 3 gigs of data an hour. So
wow.
you can't process this in a customer environment. That's really not working. Even in a cloud environment, this would not work. So you have to really shape the data in a wise way, and that is the innovative thing that we can deliver.
And I think what's really important to understand is, and that kind of connects to what you're just saying. I mean, of course, it's not a problem to record 1 hour and have 3 gigabit of data, and then you just take that and do something with that. But really, the value comes when you're able to see what is happening, for example, with the same gear on different machines, or how does the machine with this process behave today, and how did it behave 2 weeks ago? Because then you can learn about the differences, then you understand, I don't know, what difference does your new tool make? Or
yes.
Has the machine changed? Do we have, I don't know, just some practical example, our ball screw, spindle bearing, whatever. You only understand that if you really create data over a longer period of time, and ideally over multiple machines.
Mm-hmm. Yes, of course. You have to understand transparency. Yeah? You have to understand why is one machine behaving a little bit different. You had the manufacturing topic last week. So there are tiny differences. The question is, how important are they, and how do we cope with that in the software? Yes.
And actually, we just touched a little bit that we need good data. The one thing is the data that is coming out of the machine, traces, whatever. There's a lot of data actually available, and it is amazing what all you can read out of that data, especially if you collect it over some period of time. Mm-hmm. But for example, we have a solution that's called smart tooling. So basically, we scan the fixtures that are coming into the machine. Mm-hmm. We scan the tool that is coming into the machine. So we can connect what is happening in the machine to what equipment did we use while this was happening. And so that's all. So for me, that's about making sure that the right data is available, and that's a full stack of data. Even though I know full is never achievable, but the relevant part of data.
Yeah, I mean, it's really the steps you make. Yeah, first you have the connectivity. Yeah, the idea was, okay, how to make a fixture smart that you can connect it really to the machine, not just physically connect it, but also digitally connected. And this is our ways to scan it, because the code is very easy to deploy. And then you connect digitally the fixture with the machine. And then in the next step, you can create visibility. Where are my fixtures? How do I deploy them over my shop floor? How do I use them? And the next step then is transparency, connecting this data with the results. Yeah? Where do I have quality issues? And does this correlate with certain fixtures that I use?
It's funny, just by the way, you just mentioned the next step of data necessary, and I think this is very important. You just mentioned quality data, and also this is a very, very important part of when we want to understand what's happening in our production, because having a set of data is one thing, but having an information that judges this data as, in the easiest way, good or bad, good gear, bad gear, in tolerance, out of tolerance, or also giving us information, where are we in the tolerance, what changes do we see, that really helps us to maybe even understand we're gonna have a problem quality-wise before we see it on the CMM in the end, right?
Mm-hmm. Yeah, so the quality of the end product, I think, is the highest need of our customers. If you buy a Klingelnberg machine, you spend money in buying high quality and high precision, but then there are many more influences that could lead to bad quality, like raw part changes, like heat treatment changes, and anything else, floor movements and whatever, and this could lead to quality problems. And our way that we are going is really to deliver a solution where you really can make this quality problems visible, and in the end, in order to predict your quality outcome. That is our way to go.
On the other side, when we don't only talk about visibility, transparency, predictability, but we also, and I think it's also important to understand, we always talk about vertical and horizontal solutions. Mm-hmm. And I think this is, for me, it's easy to connect. The vertical solution is basically, for me, it's a deep dive into one machine, one process. So we're looking at one item basically in our production and trying to deeply understand what is happening there. So basically, there we're creating a digital twin. That's basically what we're doing there. Mm-hmm. And then there is the horizontal view, and I mean, I think.
I can jump in. So we got more and more the requests of customers who are asking, how can I deploy this beyond this one Klingelnberg machine? How can I deploy this on the whole shop floor? And this is where we are talking about a horizontal solution. So right now we are offering several horizontal solutions which do not only apply to Klingelnberg machines, but they can be applied to a shop floor. Not in the deep when it comes to process understanding, but again, I can make my whole shop floor visible, and I can understand why is my OEE of this machine going down, and I can analyze this on a high level. And this this smart tooling is the same thing. You can apply smart tooling to any kind of machine, and this can run on every shop floor. And then you can add a vertical solution to this, like DDQM, so our smart tracing solution. That's basically a software product, what we are developing, where you then can do a deep dive into a single machine and understand its behavior and learn about frequencies and critical frequencies and how to solve these problems.
It's interesting. I mean, you just mentioned DDQM. We will talk a little more about the details of the different solutions in our next podcast. It's just too much for this one.
Maybe I just threw it in. DDQM means it's our initiative for data-driven quality management. So we strongly believe that the future of all these data solutions are really the gatherings of data and the ability to predict the future outcome of quality. And this is what we are doing now, and we are putting high efforts in. So the DDQM is the initiative, and smart tracing is the first product which we deploy now, where you can do really the deep dive into the machine and the machining process.
It's interesting because you just mentioned that we're also trying to, on the overview level, on the horizontal level, also to connect machines that are non-Klingelnberg machines. And I mean, I think this is also something as a strategy. We have started quite some years back. For example, if you look at our closed loop, we based it from the beginning on the GDE format, which is a publicly available standard, so everybody understands that. So it's not closed shop Klingelnberg, but the idea really is, I mean, you're anyway, as a customer, connected to Klingelnberg, but you get a solution from us, and you can connect also to other different machines. And what's funny, I'm not sure if it's funny, but like if we talk about a smart factory, I remember our first steps, and the first steps were making visible which machine is running and when, and which machine is not running. So, you know, when you come back, when you ask yourself, why is your OEE going down, for example? And you're coming into the factory in the morning and you see, okay, last night shift, for example, this machine has not been producing for 4 hours. You can go there and understand why that is. And you have a good chance of finding out why that is. So we don't provide you the deep knowledge for the turning operation, but the information that the turning operation stopped for some time, this information is there and gives you the trigger to find out where to improve. Versus, you understand that 2 weeks later, and the numbers are coming, and they say, "Oh, what was there happening 2 weeks ago?" It's too late, basically.
Yeah, I mean, Smart Factory is a good product which shows how we think. So what our idea was, what we are really good at Klingelnberg is we know how to connect machines. We know the internals of machines, and we know how shop floors are running. Yeah? We have over thousands of machines, so we know how our customers are doing this. And many similar products in this field, they come more from the software side. So they have software developers who have an idea of a shop floor and then program something. And we are coming from the other direction. We have a service network and we have good knowledge about controllers. And this we put in the pot. And Smart Factory came out where we really do a very easy way of connecting as many machines as possible and give very easy overview on shop floors for customers. Yeah.
Hey, then I could go on talking about it. Digital solutions. It feels like forever, but actually we don't want to bore anybody. And in fact, we have another podcast coming up where I will have Dieter Schneider sitting there, and there we will talk about the different solutions in detail, what they really do, how you can use them, what they're connected within the Klingelnberg world, and what they can do outside the Klingelnberg world. So that is coming up. So maybe this is a good trigger to stop the discussion here and take the next step. And I'm very sure. I mean, at least if you like to, I would love to have you here in this podcast again, maybe sometime later. So. Yeah, Daniel, I would like to thank you very much for the great discussion we had, and a very interesting discussion.
I have to thank. Yeah, it's a good opportunity to show the big things we do.
And I hope also it was interesting for you, our listeners, and our watchers actually. And I have to correct something from the last podcast, because last time I said you can listen to us on Spotify and you can see us on YouTube. But I learned actually after it was uploaded that you can see us on Spotify as well. So it's I don't know if you would call that a video cast, but let's stay with podcast. That's probably easier for me. And listening is also so very good. So thank you very much for listening. Please leave us a like. And if you want to give us feedback, we are very happy to receive your feedback. You can always mail us at podcast@klingelnberg.com. But the information is also provided in our show notes. So thank you very much again, and hope to see or to hear you next time.
Thank you.